So you guys should be on lesson 10.3 in your notes and in your book, and this is on how to find the area of regular polygons other than triangles or parallelograms or trapezoids. So you can see the big idea is the same, as well as the biblical truth integration. You can review those, and then the objective is to divide polygons into triangles, and that would be regular polygons. And then we're also going to find the area of those regular polygons. So you need to fill in your vocabulary, which is regular polygon, and then you're going to need your formulas, which we have the area of a triangle formula, if you recall, is base times height divided by 2, or you could do base times height times 1/2. The area of a parallelogram formula is base times height, which we get from a rectangle. And then the area of a trapezoid formula is base 1 plus base 2 times height divided by 2. So as you can see, this pentagon right here, we know it's a pentagon because it has 5 sides. We can split into 5 triangles. So if I find the center point of the pentagon, I can split it into 5 equal triangles. Okay. So really then all I would have to do would be to find the area of one triangle and then multiply it times 5. So I find the area of 1 and then multiply that times 5, and that will give me the area of the pentagon. The same is true if I had a hexagon. A hexagon is a 6-sided figure. As long as it's a regular hexagon, I can find the center point, split it into equal triangles. I would take the area of one triangle and multiply it times 6, because a hexagon has 6 sides, which would mean it would have 6 triangles. If I had an octagon, that's an 8-sided figure, so I would split it into 8 triangles because it has 8 sides, so I'd take the area of one of the triangles and multiply it times 8. The opposite is also true. If I was given the area of this pentagon right here and I wanted to find the area of this one triangle, I would take the area of the total pentagon and just divide it by 5, and that would give me the area of this one triangle. I could also then go further down. If I was given the area of this one triangle on the pentagon and the base, I could even find the height of the triangle. Okay, so we're going to do some practice problems. So if you can take out the sheet that says 10.3 at the top. So number 1 says, give the minimum number of identical triangles you could divide each regular polygon into so that you could find the area of the polygon. So I would pick a side to start on. You can either count the sides or you can count the corners. Either one will work because it will have the same number of sides and the same number of corners. So if you counted on the pentagon, you'd have 5 sides and you'd have 5 corners, and it should match. So this has 1 side there, 2, 3, 4, 5, 6, 7, 8. So I would answer 8 for this. And if you want to challenge yourself a little bit, then name the polygon shape. So that would be an octagon. This one's 1, 2, 3, 4, 5, 6, 7, and then you keep going and then name the figure. Okay, number 3, let's try that. This one we're going to actually find the area. So Derek drew a regular pentagon with side lengths of 8 centimeters. So we know each side length of the polygon is 8 centimeters. He divided the pentagon into 5 identical triangles. So if a pentagon is difficult for you to draw, it's okay. It doesn't have to be perfect. So you can think of it as a house with the sides kind of sloped in. So each of those sides is 8 centimeters. And then they're all going to come to a center point to split it into the triangles. So it looks kind of like a starfish then. So he's dividing those into 5 identical triangles. Again, if yours isn't exactly perfect, it's totally fine. Don't erase it and redraw it. It will be okay. So we're going to find the height of one of the triangles right here. And it tells us in the problem that that height is 5 5/10 centimeters. So we know the base of one of the triangles is 8, and the height of one of the triangles is 5 5/10. And then we need to find the area of the pentagon. So the first thing that you'd want to do is I have to find the area of this triangle. So the area of the pentagon will be the area of the triangle times 5, because there's 1, 2, 3, 4, 5 sides or 5 corners or 5 triangles. So the area of a triangle formula is base times height divided by 2. And then I take that times 5. So again, I'm going to substitute in what I know. So I know the base of the triangle is 8. The height of the triangle is 5 5/10. Usually I'll use parentheses when there's a decimal point so I don't get confused between the multiplication and the decimal point. And then I divide that by 2. And don't forget to multiply that all times the 5 triangles on your pentagon. So you could write the area of the pentagon is equal to this. You could put that here too for your original formula. So you do 8 times 5.5, or you can do and simplify the 8 divided by 2 first. And that would be 4. This would be 1. So then you'd have 4 times 5.5. So that would be 22 times 5. Is 110. And we're finding area, and this was centimeters, so this would be 110 square centimeters. So that's number 3. So if it gets further down or you need to get in a piece of notebook paper, just label which number is which. So then I could do number 4's work over here, where Lydia is drawing a regular hexagon, which you can see here, so you could count the sides. And they're telling you how many identical triangles they split it into. The height of one of them is 4. And the area of the total hexagon is this. So they're giving you the whole instead of the part on this one. And they want you to find the length of each side of the hexagon, which would be the base of the triangle. And that is what you're solving for on number 4. Okay, number 5, this right here is a floor tile. So think about like tiles in your house. They might be rectangular. This one happens to be a hexagon. It says Greg uses 187 5/10 floor tiles for a room. The area of the room is 450 square feet. Find the length of each side of the hexagon. So if I know my area, I can divide that by the number of tiles they used. And that will give me the area of one tile. So you should have found 2 4/10 square feet. So that's the area of this hexagon right here. You can label that over here if you'd like as well. So then it says find the length of each side of the hexagon. So I would take the area of the one tile, and because it's a hexagon, I know I can split it into 6 triangles. So I'd take the 2 4/10 and I could divide it by 6. Okay. Or I can take the area of the hexagon formula, which would be the triangle formula, times 6, and then fill in what I know. So I know the area of the hexagon is 2 4/10 equal to, I don't know the base, that's what I'm looking for. It says find the length of each side of the hexagon, so I'm looking for this. So base times I do know the height of that triangle because if I split all of these into the triangles, this 0 and 8/10 would be my height. And divided by 2, and don't forget to take that triangle, one triangle times 6, because there would be 6 triangles. So you have your 6. Okay, so here I can even simplify this first. So 6 divided by 2 would be 3, and this would be a 1. So then I don't have to multiply by 2 first. So 2 and 4/10, and I would divide by 3, and divide this by 3. So 2 and 4/10 divided by 3, bring it up here, would be 8/10. And that would be equal to the base times 8/10. So then to get the base by itself, I'm going to isolate the variable. You divide, because this is multiplication, both sides. Remember the golden rule of algebra from chapter 8. What you do to one side, you have to do to the other. So 8/10 divided by 8/10. So you should remember the identity property of multiplication, that any number divided by itself would be 1. You can also check it on your calculator if you don't believe that, or if you don't remember it. So we're finding the base of one triangle, which would be 1 foot. And then you can work the other direction. You could do 1 times 8/10 would be 8/10 divided by 2. Find the area of the triangle and then multiply it times 6, and you should get the area of the hexagon. And then you'd multiply it times the 187 and 5/10 to make sure it matched the total area of the room. But your answer overall for number 5 should be that the side length of the hexagon is 1 foot. So all of these would be 1. Okay, the last one we're going to do together is number 7. So right here, it tells you the shaded area is 12 and 8/10 centimeters. So you should be able to see that this is the same as this. So I could move this here, and then that would be one whole triangle. And then this wouldn't be filled in anymore. So I would have one whole triangle filled in and shaded in, and 5 not shaded. Okay, the directions say that I need to find the area of each regular polygon. So all I need to do is find out what kind of polygon this is with how many sides. So 1, 2, 3, 4, 5, 6 sides. I know that I have one triangle shaded already, and I know the area of it. So I'm going to take the area of the one triangle times 6 in this case because it's a hexagon. So 12 and 8/10 times 6. And my hexagon area would be 76 and 8/10 square centimeters.